Well, I can see everybody is so sad. Like, you guys not have lunch. It's about the AC. Guys, can we have a little faster AC? Anyways, good afternoon, everybody. Welcome to React. What number is this, Kiran? 95, yeah. React 95 kilo. Sorry, I'm a little jammed here. I am Harshit and I'm a senior software engineer at MHK. And today we'll be talking about something related to videos, something related to how you can optimize them, how you can, probably stream them, all of those things. But it was just last night that I was actually flying to Bangalore and I met this group of founders and we were just talking about some random things. So this founder, he just shared a story with me and he's like, dude, we have a startup that's running only in India and the users are so cheap. Like they don't want to pay for anything. Like we have the base plan at 199 rupees and they don't want to pay for that as well, right? And we kind of connected on that because I also run a startup on the side and it's the same thing that I'm going through. Users don't want to pay anything. So we have this mindset of a jugaad, right? Where we just want to save on everything. Man, everybody's looking for ChatGPT free API, ChatGPT this. People are writing scrapers that can scrape API keys from GitHub and all of that, right? So it was just like today morning that I decided to change the topic of my talk. And now the topic is how to save $100,000 per year by just optimizing your videos from there, right? So I think that makes it more interesting, and we can also live upon our identities of being Indian and knowing all the jugards, right? Let's get started. So the entire next 25 minutes that I have with you, we'll be talking about a case study. Very simple case study. There's nothing hypothetical about it. It's a very realistic case study. So what we have is a typical blog page. I'm going to show that to you, which has, let's say, assume there are 10 videos. Okay. Each video is like 45 MB each. That's the size of a video, man. You are making a video from iPhone. It's going to be 45 MB, right? That's the minimum. So 10 videos, we are roughly looking at 450 MB of bandwidth, right? Let me show you what this blog page looks like. So I love traveling. So it is something related to that. I made like a road trip explorer here. So it's a simple blog which tells me that okay, these are the world's most epic road trips, right? So we have like the first post and second post and so on, right? Now we are assuming that all these are videos. So for this demo, I've just used images, but let's just assume that all of them are videos just like this one. And each of these videos, as I said, are 45 MB each. So 10 times we are loading 450 MB every time we are trying to load this web page, right? Now, typically, can anybody tell me if they've worked on videos before? Where do you typically store your videos? You store them on the server within the project? Sorry? CDN, right? But CDN is not for storage. Where do you store them? S3, right? You store them in S3 or there's StoreJ and so many other storage buckets, right? So typically your videos will be stored on S3 or any similar bucket which can actually help you stream the video from there, right? Now that is the base that we are looking at, right? Now imagine you were to load 450 MB of videos every time you load this page. Now you have, let's say, 10,000 visitors per day on this blog, right? So we are roughly talking about 10,000 into 30 per month. That is the amount. So it is roughly 300,000 visitors in a month, right? So 300,000 times 450 MB of the bandwidth is what you will be paying to AWS just to get that video from there, right? Get those videos from there, right? Now, can anybody estimate this cost? Like what will be this cost per month or let's say per year that you're spending just to store 10 videos and serve 10 videos from S3 to, let's say, 10,000 visitors per day. This is the most realistic number I can come up with. $10,000. That's too less, man. You guys want a hint? That's the figure.
3.6 million.
Sorry? 3.6 million. Must be so rich. No, well, so that number roughly comes up to $10,000 just for 10 videos. 10 videos for a year with just 10,000 visitors per day. That's nothing, right? Like most websites have typically like million visitors per day, in that range, right? This is just what 1% of that, right? And for that we're paying 180,000. That's like too much, right? So this brings me to a point that we need some kind of optimizations that we need to do, and it is like it's not even a want or it's not even like something that's a luxury. It is something that is a necessity now because you cannot be spending 180,000 just for 10 videos, right? In a typical setup, you would have much more number of videos, right, on a website like this. So we would need certain kind of optimizations. Now, has anybody worked with images before? Images on the website, images on the app. Do you guys know about Lighthouse, Google Lighthouse? So they have, like you have an extension in the developer tools as well, right? So where you can see what, like how your web page is performing based on the images that it has, based on what optimizations you have done, right? So that brings me to a point that, you know, when it comes to images, even Lighthouse has a lot of metrics, right? It has, you know, it basically checks and tells you whether it's correctly resized or not. It tells you whether the images are in proper format, the newer formats, WebP, all of that, and not just PNG and JPG, right? It has suppression, lazy loading, it has tests for all of these. But when it comes to videos, there's nothing. Even Lighthouse cannot, you know, tell you if your website is optimized for videos or not, because of the sheer size of videos, right? Because of the sheer size and complexity of how you can stream videos out, right? So the only two things that Lighthouse provides for videos is whether the video size is too large or you know your JavaScript main thread is blocked or not. Those are the only two checks that Lighthouse has, right? So now how would we optimize it? How would we figure out that you know we are doing the right way or not? To assess video optimization, there are only two ways. You check the network panel and you check what your users want, whether you know the visual quality is impacted or not. So those are the only two ways. You have to do everything manually, right? So that is what we'll see in the demo today. So I will be opening up the network panel. We'll just go through the videos. We'll just see how everything works, how we can stitch everything together and optimize it. You know, reduce the size. And at the end of this, we will see how much we have saved in terms of money. Right? Anybody has any questions so far before we get into a little React code?
Even for videos, we have these options, right? Preload, prefetch.
Yeah. But Lighthouse doesn't have metrics ability. So those are something that you'll have to, you know, configure on your own and then see how it works on the web page. That is what we're going to do, right? So I have like a bunch of strategies in place. So we'll be talking about, you know, each of them one by one, and we'll see the demo and we'll see how, you know, that impacts, right? So the first strategy is always use a CDN. Now, can anybody tell me what's a CDN? Like, what does a CDN do?
Content delivery.
Everybody knows the format. What does it do?
Caches your images.
Caches your
Assets.
caches is there.
It will create just a region wise and it will cache the video so that in a region everyone is
Right. So the keyword here is that in a region, right? So when you have an app that is working at a global scale, you have users from across the globe, right? You have different regions. Somebody might be coming from Singapore, somebody from probably India, or Bangladesh, or Pakistan, or maybe West Virginia, where the recent outage happened. So the idea is that the users are spread across. Now you want every user to have the similar performance and similar experience across your website, right? You don't want that your servers are in Singapore and somebody is accessing from India and it's taking a lot of time to load, right? You don't want that. You want something which is consistent across, right? So CDN basically helps you with that. So what it does is it caches your assets on these edge nodes which are available in every geographical location, right? And it serves from there. Now, there are certain CDNs that also have tie-ups with these ISPs. So, for example, if you have Jio, right, and if you probably stream Netflix on Jio, so Jio has like a tie-up with Netflix CDN, so that all these Netflix, the most accessed movies are cached on the Jio's zones, right? So that's how it's so fast, right? So that's the role of a CDN, right? So now, typically you should always use a CDN when you're serving videos. let's see what is the impact that it creates, right? So we've seen the website, right? It's a very simple static website. Typically, you would have all this data coming from a database where you just put in this text and some videos and all that, right? Links to the S3 buckets and all that, and you just render this, right? So let's look at the code. It's a very simple code. You just dive into this component. This is the road trip card. This particular card that's being rendered, right? So all I'm doing is nothing quantum physics or something. It's just a simple React code where I'm just adding certain tags, showing up some headings. Now the data that I have for this is I'm not using the DB. I have just hard coded the data and the URLs, right? So this is where the data is coming from, just for the purpose of this demo. But typically this can come from any database that you have, right? Now, if you see, there's something called a media type here, right? So media type is a video. So like the first post has a video, the next few posts has images, but typically you can have all of them as videos, right? Now, this is where can you see it or should I zoom it? Is it better now? Yeah. So now the first example that I have is very simple. So what we'll be doing is we'll be using the standard HTML5 video tag. This is something that is inbuilt in every browser, right? It's just video, like the video tag HTML, that's the simple HTML tag. And we are just going to be rendering using that, right? So the URL for this, so basically I'll tell you why I've used this. So this is just a wrapper that I've created over the native video tag. If you see, this is the native tag, and I've just created a wrapper so that I can just organize my code better, right? Now, for the first demo, this is something which I have. This is like a private S3 that I have. So I'll be showing you how a video loads with this, right? So let's go to the demo. Let's open the network tab, right? And let's try to load the video. Can you see that? Can you see how much time is it taking for the video to load? So it's typically a roughly 45 MB video, and it's still not loaded. Always loaded now. So it took roughly 14 seconds for us to load that video from an S3 storage. Right? It's a menu storage. It could be slow, right? Now, and do you see the size? The size that is transferred over the network, that is roughly 45 megabytes, right? 45 MB of the video is being rendered. Now imagine if you had like 10 of these videos, you are easily consuming 450 MB of your egress cost and your user's bandwidth as well. Let's say the user is on a 2 GB per day plan. Your one website load is taking up like 25% of it. So it does not make sense, right? Now, the first optimization that we talked about, that use a CDN. So now let's just use a CDN. So now I've already uploaded this, I've connected the CDN to the S3 bucket. So I just have the CloudFront URL, and I'm just going to do this, and let's just reload the page and see. Do you see the speed that we have now? So we are at 40 megabytes, and we are now at 45. So roughly, if you see, it took us roughly 14 seconds compared to the earlier 17 seconds, right? So we're still saving 3 seconds, but we are still loading the entire 46 MB on our website, right? So what CDN will give you is CDN will give you the benefits of speed, not the bandwidth. The bandwidth will still be the same because the video size is that large, right? So now what would you typically do now? So typically what you should do as a second step is load writer videos. Now how would we do that? So we have certain formats. For example, right now the video that we loaded, that is an MP4, right? So you can actually see here the headers. If you see, is it visible? Yeah. At the back, is it visible? Or should I just zoom it? Okay. Is this better? Okay, alright. So if you see the content type here, so the content type that we are loading is actually video/MP4. Right? So the original file is MP4 and we are still loading the MP4 file, even though it is on a CDN, right? And we are consuming 45 megabits of bandwidth, right? So now, how would you typically load? I mean, how would you convert this to a smaller video? So there are multiple formats, right? There's MP4, there's WebM. WebM is a more modern format, right? So now these formats, what they give is they give you this benefits of retaining the same quality while reducing the size of the file, right? So now like you would ask me how we should do it, right? So the simple idea is that you use something like FFmpeg and just convert the video and upload the video to S3 with the WebM format and just serve it from there, right? So it will typically reduce your video to something like 20 MB, right? Now this takes a lot of processing because now typically in a pipeline, if you were to do for like hundreds of videos, you'll have to manually run this command and convert the videos and then upload it and serve it, right? All that is just very time consuming and very resource intensive as well, right? So here I would be using something which we have developed. So it's called the ImageKit Video API. Now what it does is it just automates this entire process for you. So let me just show you what we would be doing here. So I'll just change this to ImageKit. Let's just talk about what we just did. So ImageKit Video again, it is a wrapper component that I've built, right? Now the thing is, here if you see this is a capital V. So this is not the standard HTML tag. So this is the tag that comes from ImageKit's React SDK. But internally we still use the standard HTML tag. The only thing is we give you options like URL endpoint which can automatically connect to ImageKit's URL so that you don't have to put the SRC manually. Right? So just the basic things and some optimizations that ImageKit gives you out of that. Right? But base is still the HTML tag. Right? If I can show you this. Yeah, I think it's not the yeah, but it's the same thing, right? Now if you see this, if we go and reload this page, let's just try to increase the size. Yeah. So if you see, now the content type is delivered as WebM, right? So this is something that ImageKit automatically does it for you. So as soon as I'll show you where this video is on ImageKit. So this is the video, driving.mp4. This is the same video that I've uploaded here. Now ImageKit has some default settings on your media library. So this is where it comes from. So if you see this, right? So what we do is we optimize video quality automatically during delivery, right? So there are certain defaults which basically figures out that your browser supports WebM, so we'll just deliver WebM. You don't have to convert it yourself, right? So all of these things are something which we have automated in the API. So if you see now, we have loaded. See, the video is still playing, right? We have loaded just 8 MB of data. So from something like 45 MB, we have almost cut down the video size to 8 MB just by the format conversion, right? So we have converted from MP4 to WebM, and that has given us roughly, what is this? This looks like 80% of savings, right? So 45 to 8 is roughly 80, 70, 80%, right? And we have also reduced the time that it takes for the video to load, right? So just 5 seconds, from 17 to 14 to 5, right? Now, you would ask me how internally ImageKit works. So ImageKit also works over a CDN, right? So we have certain, transformations, certain optimizations, and then we serve over a CDN. So it's basically 2 in 1, right? And that is giving you this much saving, right?
We are storing the image on here.
Yeah, you're storing. So either you can store it on ImageKit. So right now for this demo, I've stored it on ImageKit. But you can also just, probably just link your S3 bucket here. So for example, I can just go here and I can just add, an existing origin. So for example, this is my, I can just attach an S3 bucket and it will just serve directly from your S3 over ImageKit's CDN. Okay? So that is, so your assets don't have to be moved to ImageKit, right? So what we talked about is we've now come down to something like 8 MB and we reduce the time to 5 seconds, right? So for 10 videos, we are roughly taking 5 seconds to load if we assume all of them are loading in parallel, right? So we talked about web and we have talked about compression, right? Now the next step. So the next step is you need to lower the video resolution. So now how would that work? So typically if you see, your users would be coming on this website from a laptop, from an iPad, from a mobile device, from probably like a watch if some watch supports it, right? So now essentially what I'm trying to say is that all of these devices have different screen sizes, right? Now a typical mobile will have just this much container size where you will have to load the video in, right? But with a laptop, it's a little larger container, right? Now, does it make sense to load the entire 44 MB 1080p video on the phone and on a laptop as well? It does not, right? Because on the phone, you will not be able to take advantage of that high number of pixels, right? Because it will not be visible to you. It's just a small container, right? So what you could do is you could, on the runtime, you could just lower the video resolution based on your device capabilities. Now that also brings me to another question. Does anybody know what a retina display is? Like, I'm sure people have heard retina displays in MacBooks, right? Does anybody know what a retina display is? Sorry?
Screen having
A screen has a
double pixels.
double pixels, right? So typically when you talk about a screen, right, it is just like a 2D array which is made of pixels, right? So when you talk about something like, let's say 1920 into 1080, right, that is what we call Ultra HD, right? So it is just 1920 in the width, 1920 pixels like this, and 1080 pixels like this, right? That's the matrix that we are getting. Now with typical retina displays, the display size is same, but that one small inch of that display will have double the amount of pixels. So now typically when you want to load a much clearer video on a retina display, you will have to have 1920 into 2 times and 1080 into 2. So roughly a 4K video will play as like a Ultra HD on a retina display. That's why we get the clarity, right? So now this is something that we call DPR, density pixel ratio, right? Now for most older devices, this value is 1 because for one inch of the screen, or let's say 1 millimeter of the screen, there's just 1 pixel. But for retina, there's 2, right? So the DPR value for retina displays is 2. Now we have certain other devices also which have higher values, 3 and above as well. But typically, the larger market is covered with 1 and 2, right? So now let's talk about how we would lower the resolution, right? So let's say in this case, if I were to lower the resolution, all I have to do is there's this transformation, right? So I can just maybe give something like width why is it? But let's just add it to 10. So let's say if I fix the width to 540, right, and then I try to load the video. So do you see here when we're trying to load the video, let's just refresh. So do you see there's certain level of blurring that happened to the video, right? Now this is because we tried to load a 540 pixel, like the 540 pixel video in a frame, in a container which is much larger in size. But now when I reduce the size of this container, it looks fine, right? Now, how do you do that dynamically? So this is something that I've done statically, right? I've just, asserted that, I want to load this 540, the dimension of the video. But if you were to do this dynamically for all these different screen sizes, which start from, let's say, this to something like this, and it should just happen automatically. How would you do that? You have no way to do that, right? You will have to just create multiple variations of the video, serve it according to the size, right? Now that is something which ImageKit does automatically. So all I have to do is just still be saving on a lot of bandwidth depending on the screen size. So if I have a smaller screen size, it will automatically load a smaller video, right? A smaller video with lower dimensions, right? So this is how you can just probably lower the video resolutions. Now,
How is it able to detect them?
so this is basically how it works. Is if I show you the request that's going, there is something called sec headers. Okay. So do you see this sec headers? So there's, I think right now it's just sending. It's not sending one header. So there's something called sec DPR header as well. So this is something that all browsers send with each request that it makes to the video file, right? So it tells you the DPR and it tells you the container size as well, right? So based on that, what we do is we internally process the video. We have multiple variations of the video created, and we just serve them on the fly for you based on that asked dimensions.
So let's suppose that it is not a real case scenario, but like when I am increasing the resolution size, so will it again call the API or
That is something that you'll have to implement on the React side, right? So that is because the call is something that you are controlling in your React application. It's not something that we are sending from there, right? So once you just recall that with the decreased screen size, you will be able to get those responses.
Is there a copy of this always stored?
Sorry,
Different screen sizes, different image sizes.
different. What is the question?
Every image, when you resize it,
Right.
it has to be cached.
So what happens is all of this operation happens on the fly. So what we do is we do not create these multiple copies beforehand and we store them and we cache them now. So the first time you call for that particular dimension, we'll create it on the file, we'll process it, and we'll store it on the cache, and then we'll serve it for the upcoming requests.
So there's a lot of CPU for it.
Yeah, there's a lot of CPU usage, but as like on the end consumer side, you would not feel lag because the power is intense. Okay? So you would not feel a lag. Typically with videos, you would still feel a few seconds of lag because of the sheer size of the video. But for example, for images, we do this for images as well. Now that is very instant, right? But we do not pre-process it. We do it on the fly.
so in my caching there will be multiple videos for like with multiple
Right.
But we still have CloudFront in front, right? Active cache.
Yeah. So we internally have a CloudFront, but if you want to use any other CDN of your own choice, you can use that. We will integrate it. So we would just take care of the transformations and optimizations. The CDN will still be yours. So a lot of like our customers use Akamai as their CDN. They do not want to migrate. So they just use us for the transformations and optimizations, but still retain Akamai as their primary CDN. Right? Any other questions? I can move on to the next part. Right. So we were talking about can you remove the audio? So when it comes to images, right? Images are very simple objects to work on, right? Because it's just like a matrix of pixels with different colors. Right? But videos, it's not the case. Videos are much more complex because they have a video stream and they have an audio stream. Right? Now, typically, an audio stream will also consume some amount of size. Right? So, for example, you have websites where a video is just playing on the background of your website. Right? So there you typically don't need an audio. Right? So you can actually remove the audio, and that would again save you a lot of bandwidth. Right? So the idea is, with all these strategies, we are trying to reduce the bandwidth over the network, right? Because that is something that is costing you a lot. Right? Now, there is a very interesting concept called ABS. Does anybody know what ABS is? I'm already given the hint. Has anybody seen YouTube? The player has different resolution options, right? You have starting from 360 to 4K to 8K, right? So that is something which we call ABS. ABS is adaptive bitrate streaming. So what happens is that now typically your users would be in different network conditions. Right? Somebody would be browsing in a metro. Somebody would be browsing from an office space like this, which supports a higher bandwidth, right? Now, how would you adapt your videos for all of these network conditions while still making sure that they don't buffer? Because, come on, we don't like buffering, right? Nobody likes buffering. So, how would we do that? Any ideas? Let's say I am on a 3G network and I still want to play a 1080p like HD video without buffering.
Reloading. We'll have some chance and then while the video is playing. So
Yeah, you'll have some chunks while you preload, but you will have to process these videos, right, in these different resolutions based on the bandwidth, right? Now, how would you select which chunk or which file to load based on the bandwidth? How would you do that? Now, that is something which you'll have to implement. Now, the good news is that most video players that you get, so if anybody has worked with videos, there's Video.js, there's HLS.js, all of these open source libraries in React. Now, what these libraries give you is they have these implementations within themselves where they would be able to detect your user's bandwidth and then select a particular stream to play for that particular bandwidth, for that particular device, right? So, now this is typically done by two protocols. I don't know if I have them on the slide. Oh no, I don't have this now on the slide. So there are two typical protocols. One is called HLS, which is HTTP live streaming, right? There is another called MPEG dash, right? So these are two protocols. Now what these protocols do is they create something like a manifest file, okay? A manifest where they would typically mention that, okay, for this bandwidth, let's say the user is on a 1 Mbps speed, for this bandwidth, load 360p of the video, right? So they would just be able to do that, but you will still have to give it the URLs of all of these different variations of the videos, right? So 360, 480, 720, 1080, 4K. You will have to supply it those videos, and then it will create a manifest, and it will read from this manifest, and it will just load according to the user's bandwidth, right? Now, again, as complex as it sounds, it's very difficult to implement, right? Because you will have to pre-process all of this. Let's say you upload a video. Anybody who's a video creator who uploads videos on YouTube? Anybody who's ever uploaded a video on YouTube? Do you see when you upload a video, before it goes live, it takes like 15-20 minutes for it to go live, right? So during this time, what it does is it actually does this process, where let's say you shot the video in 4K, it will create all of these different variations, right? It will create, let's say, 7 variations starting from 360 to 4K, and it will store each of these different variations of the file on their S3, cache it to the CDN, and then start doing that. Now again, YouTube does a lot of other things as well. It does the transcriptions, the closed captions, and all of these things. So all of that happens in the background, right? Now imagine the amount of CPU usage that you would need to process all of this, right? The amount of CPU usage, the amount of storage that you would need, because now you'll be creating multiple variations, right? So now, typically, ImageKit's video API also gives you that. So I'll be showing you how we do that. So again, we'll go to the road trip card, this component, and so this is my implementation of the HLS video player. So if you see, this is the open source library that I'm using. It's called hls.js, right? You can also use video.js. They have similar implementations for supporting APIs. Now, again, what I've done is I've just used the HLS player, and I've just created a wrapper over it, just so that I can organize the code better. Again, in the base, it still uses the HTML tag, right? HTML5 video tag, right? So that is what HLS does. But again, it gives you these options where the whole manifest file and switching between different things. All of that is handled with HLS.js, right? So now that I've just switched this, and I made the change, let me just use and demonstrate how this works. So now if I clear and if I reload the video, now you see the first request was not MP4. Like it is not the driving trip video that we was used to do. So now what happened here was that now because we are serving, so this video is already hosted either on your S3 or on ImageKit's bucket, like this media library. So this is the original video. Now what we done is in front of the video, right? In front of the actual video, we just appended. So here, right? So this is the manifest here. So this is how we create the manifest here. So this is the standard URL path. Now what we've done is we've just appended something called ikmaster.m328, right? So that is a suffix that we append in front of your original URL. And what internally which it does is it will create all these different variations of the video. So you will have to tell that which variations you want. So once you basically tell which variations, so 360, 720, all these variations. I'll show you where that is. So you see this string. So we are just telling ImageScript that we want 360p, 480p, 720p and 1080p variations of these videos, and we are appending this. Just these two steps. And what we internally do is we create all these variations, we put them on the cache, and we start serving from there. Right? Now, typically this M3 URL is the extension for an HLS manifest. That is being called, right? So if we look at this, if you look at the preview of this is not a stream. Can everybody see what is the content of this call? So this call is not a video stream, it is not a chunk. It is actually a manifest file. Now, if you see, what we have is, we have these different URLs of the same video, of the different variations that we created of the same video. And we also have the resolution for that video. This is 360p, 480p, 720p, 1080p, right? And we also have certain threshold bandwidths, right? So for example, for this bandwidth, we instruct the player to load this particular video file from this URL. This is what the manifest tells the video player, right? Now, if you see, this was the first call that happened. So we loaded the manifest, and now the video player started from the first variation that we have, right? So basically, what happens is these video players, what they do is they start with the base variation because they don't know what the user bandwidth is, right? The network bandwidth, the network speed is. So they will always load the first chunk in the base variation, right? So the base for us was 360p. So the first chunk that you see here is loaded in 360p, right? Now, when it sees that, when it detects that the user is on a higher bandwidth, so how does it do is that it will just take a look at these sizes, the chunk size and the timing, how much time it will take for that to load. Now, if that crosses a certain threshold, it knows that you are on a very high network speed, right? So it will start loading the next segments, 1, 2, 3, the next 3 chunks in the highest or whatever we have supplied, right? So if you see the first chunk is 360, the next 3 chunks are 1080, right? Now if you see this, the video still plays, there's no buffering, right? So effectively, what is happening here is that your users are not seeing considerable difference in their user experience, but you, on the other hand, are saving a lot of money, right? Because now you're not loading the entire. We started from 45 MB. You're not loading the entire 45 MB. You're loading it chunk wise, and you're loading roughly what 7, 9 MB, right? Yes. Sorry.
It is the the first part segment is of 360p only.
Right.
So is the first part of the video little blurry?
Yes, it is. See. Now, if you see the ending of the video, that is much clearer. It's not visible because it's a very small image that we loaded. Now, the problem with this is we have adapted the video based on the network bandwidth. But what about the size? The player is still small, right? We don't need a 1080p video in that small player. We can easily get away with 480p, right? Or let's say 720p, right? So we still have more chances of saving bandwidth, right? So now, for example, in this particular demo, we are using HLS.js. So HLS.js has something called, it's a configuration, it's called cap level to player size. Most video players have it, they might name it something else, but it's the same thing. So now what it basically tells is that it will, take into consideration the container size that you're loading the video in. And you can just, for example, I just comment this, uncomment this, and this is another config which is max device pixels ratio. So we talked about DVR, right? So here I can also limit it max to 2. So I don't want this video to play anywhere above Retina displays, right? So now if you see, if I reload this, do you see the difference? Now because it's a smaller size, it did not, even though I'm on a high network, it did not go above 360. It's still loading the other chunks in 360, right? Let me increase the player size for you, show you. Yeah. Let's say this is the new player size. Let me increase it further. Do you see? Now it again started with the 360p chunk, but then it detected that we are on a higher container, the larger container size. It upgraded to 720, right? So with these configurations, let's also try one more demo where I'm going to. So with DevTools, right, we have this network emulator where you can right now set to no property, right? So let me just set it to something like slow forging. Okay, and then try to reload this. Where is it here? Yeah. So now this is typically emulating a slower network, a typical slow forging network. And the expectation is that here we would again start with 360, but we would not upgrade it to 1080 because 1080 would not be supported. Now, the thing is with whenever you emulate the network, it will emulate the entire call. It will not just emulate the video call, it will emulate the entire web page, right? So see, now the video is started loading. We started with the first segment, which is 360. The second chunk was also 360 and so on, right? Even though the layer size was big, right? So ideally, if it was a full speed network, it would have just upgraded. See, it just upgraded to 720.
There are two calls. One is
Just a second. Oh, it's, I think it's too large. I can't see. Yeah.
there are two calls. One is 360p-pl.spa and
Right,
the other
right.
is sets.
Right. So I was actually going to come to that. So the first call is basically the call to the root manifest. So the root manifest basically tells you that based on the bandwidth, what particular video file you have to call, right? And now, if you see all of these, right? You see this. So these are again not video files. These are again sub-child manifests. So what we are doing is this is a root manifest, and in that we are again storing different manifests.
Okay, so based on resolution, we have different.
Right. Like based on resolution, we have different manifests, and in that we have the URLs. So I can show you the second column, which is the 360p. Now this will have the actual URL. If you see, this has the chunks. You see the chunking now? So first chunk, second, third, four chunks.
And how is the chunk?
So the chunk, so basically this is called segmentation. So segmentation is something that most players do it on their own. So each player has different limits based on the browser capabilities, and they would request for a certain chunk. Now for a typical lower bandwidth setup, these chunks would be smaller in size so that they load quickly, right? But let's say you are on a higher bandwidth, these chunks could be larger as well, right? So for example, in our case, we were loading roughly 2-3 MB of chunks, right? Or 4 MB of chunks as well. So if I was on a, let's say, 3G network, these chunk size would reduce, right? And that's how the buffering happens, and quickly you can just start streaming, right? Any questions so far in this? Sure.
Yeah, you said it will be like once you upload a video, you will get a different variations of this.
Right.
You did cover about the frame rates.
Sorry.
Frame rates, FPS of the video.
Right.
I was just curious to know.
The frame rates. So see, when we are compressing the videos or when we are creating different variations of the video, we do not change the frame rate, right? But there are certain transformations that actually do change the frame rate as well. For example, if you go for something which is a lossy compression, right? So there we would typically change the frame rate to, let's say, from 60, if it's short of 60 FPS, you would typically reduce it to something like 50 fps, or let's say even lower to 30, depending on whether it's being streamed on your mobile device or on your laptop. Because on a typical mobile device, a 30 FPS video will also play properly, but not on something like a MacBook with a Retina display. And especially if the video is shot at a higher FPS. But then we also have certain base limits there. So, for example, something that you shot in 120 FPS, we would not reduce it to 30 because that's like a huge loss in the frame rate. Any other questions? Yeah.
So you were saying that network was not very good, these chunks might be smaller.
Right.
When are these chunks created then? Are they also created on the fly? Because they have you're actually put in the manifest, right?
No, these chunks are in process. They're not created.
So the choice will be based on that, not
So for each different playlist, the chunk size is different. So for example, right now we are loading the
Choice
360.
will change, not the chunk.
Right. The choice will change, not the
You can
chunk.
only choose from the chunks which you have already created.
Right.
Okay.
So the chunk size is typically driven by the protocol itself.
No, no, oh, sorry. So, as a developer, will I create those chunks or like?
So if you were to typically use something like FFmpeg to create these chunks and to process the video yourself, you will be responsible for creating the chunks. But like I said with ImageKit, we do it ourselves. So the only two things that you have to do is just add the suffix to the URL and tell us which variations you want. That's it.
So this image kit, so I'm sorry, but I was thinking about a video here. These are runtime tools, right? So while you are uploading to some of your dashboard, then it will happen, right? Because here it is runtime, right? When code is running.
No, so there are multiple ways. So either you can do it on the fly when you're uploading it, or you can also do it when the first call to that video file happens.
You mean segmentation we can do runtime?
Yeah.
Okay, but that will be
Yeah, that will be a little delayed. So probably you'll have like a few seconds of delay till we process the video and make it ready.
yeah, but essentially this is runtime, right?
Yeah, essentially this is a. It's
So
not like-
player can't do it by its own, like we
No,
have to
no.
make players up.
There needs to be a server set up to do this. The player cannot. do it.
Yeah, all right.
Right. Moving ahead. So now we have looked at the player size, and we have also looked at the network conditions. Now the question is, do you really need adaptive streaming? So the question is, do you really need adaptive streaming? So, for example, if your video is, let's say, 5 seconds, right? For example, I have this website, we have our homepage. So typically, if you see, right, now this is not a GIF, it's a video, it's an MP4. If you see, this is an MP4 that we have uploaded, right? Now, this is a very small duration video, right? So you can typically assess whether you would need ABS or not, because again, ABS is something which is very expensive for you to compute, right? The pre-processing and all of that is very expensive. So you'll have to take informed decisions whether you need it or not. So typically, let's say if your videos are over 20 seconds, right, where the segmentation will actually help you, that is where you should go for ABS. Otherwise, you should not go for ABS, right? Now, with ABS, another thing that happens is the quality also changes, because based on the network, based on the player size, the quality changes. Now, in certain use cases, you would have to stick to the quality. For example, on our website, we can't afford to have a lower quality video playing, right? Because that's just a business call for us, right? So in those cases, we would not go for ABS, right? We would just try to stream it directly, right? Now, the other question is that let's say you have a website where there is a video on the background that's playing with like a tint, like a filter over it. Now in that case, you have to ask yourself a question that you need a higher quality video ever or not, right? So these are the 3 questions. If you ask these questions and get answers to these 3 questions, you can decide whether you want ABS or not, right? Now there are certain other strategies as well. For example, now these are mostly UX-based strategies, right? So, for example, let's say when you're loading a website, don't just autoplay the video. Let the user interact and play the video. That saves you a lot of bandwidth. Let's say the user did not even want to stream the video, right? So now you will end up saving a lot of costs there, right? So you can also control preload. So there is something called preload tag in this native HTML5 video tag. So you can control whether, basically how many seconds of video you want to preload, right? So all of that basically helps you to save a lot of on the bandwidth, right? Then again, lazy loading is something which we all know, right? Don't load a video until it comes in the scroll view, right? So when you're scrolling on the top, there's no video on the hero section, but there's a video somewhere at the bottom of the line, right? Don't load it. Load it when it comes into the view, right? So that's lazy loading. Again, this is something that everybody forgets. If the scroll view, if the video is going out of the scroll view, remember to pause the video, because you will be saving a lot of battery there. If your video is not playing, it will not load the next chunks, right? So if you don't pause the video, you will load unnecessary chunks. Right now, these are the things that you need to consider when you are developing a website which has videos. Now, coming back to the case study. Typical blog page, 10 videos. Now we have reduced the size to something like 5 MB. Right? After all of these optimizations, you can typically reduce to 5. Like if you are doing a chunking, we were already down to something like 9. Right? Similar setup. We have reduced the size to 5 MB each. Total of 50 MB. This is the ceiling parameter. So typically, I can show you how I've arrived at these numbers. I just set the complexity. Typical monthly CD and egress costs for this, and it tells me that for the initial setup, this was the cost, monthly cost. So this $15,000 times 12 is 180,000. And I did the same search with 50 MB of data ingress, right? And now that brings me to $1,000. So 1,000 into something like that is $15,000. So we are roughly coming down from 180 to 15, about 92% of savings. Right? So just to summarize, what are the different strategies for video optimizations? Use a CDN, compress, use modern formats, use modern codecs like VP1, resize videos, use ABS with proper resolutions, use ABS only when necessary. Don't just go for ABS because it's fancy. Wait for user interaction. Don't just autoplay the video if it is the use case. Control your preloading, lazy load. The same thing goes for images. Lazy load, always lazy load, and pause the videos when it's not in use. I think that brings me to the end of this talk. I don't think we have time for questions, but I'll be around, so just hit me up. Thank you everybody, and I hope you have something to take back from this talk.